Okay, here we go. Put attention, please. Your H value. What's your H value? 0. What's the K value? 0. So you're not going to be shifting anything, right? Remember, H is always with X. Is there a value up here with the exponent X? It doesn't say X plus 3 or X minus 5. The K value is what you're adding and subtracting at the very end. There's nothing there. So there is no H or K. There is no translation. There is no shift. So normally you start with H and K, then you ignore H and K. There is no H and K to ignore. If you want to just keep going with what we always do, box it in, go for it, no problem. Let's jump to an XY table now. So an XY table, let's use consecutive integer inputs. So there we have consecutive integer inputs. They are in order, right? And now let's plug in an easy one. Which out of all these inputs would you like to plug in? You could do -3 if you want, but the easiest one would be 0, right? I mean, think about this. If you were to plug in -3, the -3, you'd have to distribute the exponent -3. Because it's negative exponents, you have to flip it over. Then you have 4 to the third up on top. Then you'd have to multiply it by 8. It's a lot of math, right? How about this? How about we just go with the easiest one? 0 right there. 1/4 to the 0 power is? What? 1. Okay, so 1/4 to the 0 power is 1. And 8 times 1 is 8. So when I plug in 0, I get out an 8. Now I could continue to plug in and work out the math. The easier option is to recognize that this is a decay function. Why is it a decay function? Because the base is less than 1. So how is it going to decay? It's going to decay by 1/4. So if I want to make this 8 decay by 1/4, I need to multiply 8 times 1/4. And 8 times 1/4 becomes 8/4. And 8/4 is really 8 divided by 4, which becomes 2. Are you with me? And then, how would I get to the next output? This 2, I need to make it decay by 1/4. Multiply 2 times 1/4, you end up with 2/4, which ends up giving you 1/2. And then you want to decay this 1/2 by 1/4, so you're going to go 1/2 times 1/4, and what do you get? You get 1/8 when you multiply 1/2 times 1/4, right? So as you could see, it's decaying. The 8 went to a 2, it went to a 1/2, it went to a 1/8. The next one would be 1/32, which is hardly anything. It's already super close to 0. So what happens as we go, if we're going down, we're multiplying by 1/4. As we're going up, we're dividing by 1/4. Now when you divide by 1/4, you're really multiplying by the reciprocal of 1/4, which is really multiplying by 4, right? You could clearly see, how do you get from 2 to 8? You multiply by 4, right? So what would the next one up be? 32. Now that's already off the graph. I could stop right there. I mean, I could keep going 32 times 4 and get 128, but that's pointless because the graph is only a 10 by 10 graph. So just with these coordinates right here, I already know exactly what my graph looks like, and there is no H or K shift, so I'll be ready to rock. So if we go 0, 8, 0, 8 is right here. If we go 1, 2, it's right there. If we go 2 and then half, it's right there. And then 3 and 1/8, that's already hardly anything. So we already know the perfect graph here, and we know it infinitely approaches. We know it's going to keep getting smaller and smaller and smaller. So we just start, it looks like we're touching the line, but we know it never actually touches, just infinitely approaches. So we're going to draw it right on there like if it is touching, but we know that that's not really the case. And here's the top part of this line. So there's our decay function. If we had an H and K, we'd just translate it, shift it according to H and K. Shugare? All right. Did you say shu yes? So let's jump to this last one. Let's go through all the steps here. Step 1 is to identify your H and your K. Help me out here. What's H?
-1.
-1. Excellent. That means I'm going to go 1 in the negative direction after I plot my points to the parent graph. How about my K value? -3. That means I'm going to go down 3 after I plot my points to the parent graph. So once I identify H and K, like always, I like to box them out, ignore h and k for a while, pretend that this is my only function, and then I jump to a xy table from there. So on my xy table, I want to use consecutive integer inputs. Okay, so technical difficulties. Let me go back and do this one more time. So when we plug in 0 right there, 1/2 to the 0 is 1, 3 times 1 is 3. As I'm going down, I know it's a decay function, it's going to decay by half. So 3 times half is 3/2, and then 3/2 times half will be 3/4, and then 3/4 times halves will be 3/8. Sorry, it's getting ugly. And 3/8 times halves will be 3/16. But 3/16, as you can see, it's approaching 0. Going in the opposite direction, if you're multiplying by half going this way, you're going to be dividing by half going in the opposite direction. If you divide by half, that's really multiplying by the reciprocal of half, which is multiplying by 2. In other words, if you're going half going down, you're going to be doubling going up. So the next value up would be 6. The next value up will be 12. And at that point, you're already off the graph. So let's plot these points. So we have 0, 3 right here, -1, 6, and we know -2, 12 is already off the graph. We could put it up here if we'd like. But going in the positive direction on x, you get 1 and you get 3/2. 3/2 is really 1.5. So you got 1.5. Let me zoom in right here. So 1.5 would be right here. When I plug in 2, what do I get out? What's the coordinate out there? Wow, thanks guys. 2 and 3/4. Fantastic. All right. So 2 and 3/4 is right there. And then the next one, 3 and what?
3/8.
3 and 3/8. 3/8 is less than 4/8, so that's less than half. And as you can see, it's going to be decaying down to 0, practically to nothing, right? Even though it never actually touches, just infinitely approaches. So we have those coordinates. To graph our final graph, what we need to do is shift them, translate them according to h and k. So I need to take all these coordinates and move them 1 over and 3 down. So if I did take this coordinate that's at -2, 12, moved it 1 over, I'd be at -3, -9. If I took this one, moved it 1 over and 3 down, 1, 2, 3, I'd be right there. And then the other one, 1 over, 3 down, would be right there. And then the 1.5, this guy, if I went 1 over and 3 down, be right there. And not only that, it's easiest to go with your asymptote. If you knew it was infinitely approaching 0, you need to move it 3 down. So you're going to be infinitely approaching -3. So you know you're going to end up right here, like if it were actually on the y value of -3, but we know it never actually touches, just infinitely approaches. So here's my final graph using those shifted coordinates according to h and k. That's my exponential decay function. Now it is important that we also are able to state the domain and range of each of these guys. So the domain, we're talking about x values. This does go to the left forever, and it goes to the right forever. It's obvious that it goes to the right forever. Some people might think, oh, it goes straight up. It doesn't go to the left forever. But the truth is, it really does continue to go to the left forever. Because even on the inputs and outputs, you could plug in anything you want for the x's, right? Now, when you talk about the range values, we're talking about the y values. The y values are up and down on the xy plane. So you could clearly see that this whole graph is all above this y value of -3. This is the y value of -3. So when you're talking about domain, your function is all above the y value of -3. So you're going to say y is what? Greater than -3. Now you can't even say greater than or equal to. That would be incorrect. Because if you say greater than or equal to, what you're saying is that it does eventually touch. It does eventually get to the y value of -3. But it never actually touches. It just infinitely approaches.